All right, let's start with the example out of the book that we talked about yesterday. So this is the try this example from lesson 6. We are given 2 points on this exponential function, and my goal is to write the function in the form of a times b to the x power. So we talked about yesterday, maybe a good way to start is writing down the information that we have in a table. So I've got the point -1, 9 and the point 3, 16 over 9. To write my exponential function, I need 2 things. I need my starting value, which another way of saying the starting value is the y-intercept. I don't have that value here. I'm actually not given that on this problem. The other piece of information we need is the growth factor. Now, in this problem, I can find the growth factor going between these 2 points, right? Now remember, we always take a value and divide by the previous value to get the growth factor. So here I would take 16/9 divided by 9. Now, if I put that into the calculator, we actually end up getting 16 over 81. So this is my growth factor over this interval. So now I have to think, well, if I'm going from -1 to 3, that is an interval or an increase of 4. So if I want to change this growth factor, this currently is a growth factor over an interval of 4, to a growth factor over an interval of 2. So let me label here my growth factor to an interval of 1, I need to take that 16 over 81 and raise it to the 1 over whatever that current interval is, right? Again, that current interval is 4. From -1 to 3 is an increase of 4. So this will get me my growth factor over an interval of 1. If I put that into the calculator, if I do 16 over 81 to the 1/4 power, I get 2/3, right? 0.666 repeating is 2/3. Remember, we can hit the math button and then 1 to turn that back into a fraction. So 2/3 is my growth factor over an interval of 1. Now, I still don't know the starting value, right? I don't know my y-intercept. Well, all I need to do, since I know a point that is a distance of 1 away, I can just take that value of 9 and multiply it by 2/3 to get my y-intercept. 9 times 2/3 gets me 6. So writing this function, my y-intercept, or my starting value, ends up being 6, and then we just determined that my growth factor should be 2/3. So this function should be 6 times 2/3 to the x power. All right, now let's look at those 4 examples that are on your notes. This first example is actually really similar to that one that we just did from the book. So the 2 points that I have, -1, 8, and 2, 64. Okay, so I want to find the growth factor between these given points. So I'm going to take my value and divide by the previous value. So 64 divided by 8 is 8. So 8 is my growth factor over an interval of 3, right? To go from -1 to 2, I'm increasing by 3. So that means I need to take this value, this growth factor, and raise it to the, I'll just say GF for growth factor, raise it to the 1 over that jump in my x value, so 1 over 3 power. Now in this case, 8 to the 1/3 power, that works out really nicely. If we put that in the calculator, that's just 2. So what that tells me is my growth factor over an interval of 1 is equal to 2. If my growth factor over an interval of 3 is 8, my growth factor over an interval of 1 is equal to 2. So my function then, my growth factor is 2 to the x power. Now we still don't know our starting value. Now this is where we can, let me add in some values in my table here. We can kind of think about the intermediate values in the table, right? So we know that all the way down here at 2, we've got a y value of 64. But what about these intermediate values? Well, we just determined that the growth factor every 1 is 2. So that means I'm multiplying by 2. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So we can think about this as saying, well, my starting value then, my y-intercept is 16. All right? Example 2. So on this one, a function decreases by 15% every 2 hours, and at t equals 0, the value is 200. So we're actually given the starting value here, right? I'm given that the starting value is 200. So I don't have to figure that out this time. I know that's going to be part of my function. Now here, this piece of information, if my function is decreasing by 15%, we've talked about this a lot. We want to think about how much is left. So if we're losing 15%, that means we would have 85% remaining. So my growth factor over an interval of 2 would be 0.85. Now, again, to change this to an interval of 1, I need to raise this to the 1 over whatever that jump in the x values is. So to the 1 over 2 power. Now, we could put this in the calculator, 0.85 to the 1/2 power, but we're going to get an ugly decimal if we do that. So if that's the case, if we try to put this in the calculator and it does not work out nicely, we can just leave it as 0.85 to the 1/2 power. Okay, so that's probably our best bet if this doesn't work out nicely. On the third example, just given two points here. So again, let me put these into a table. So I've got the point 1.580 and 240. So if I want to figure out my growth factor first between these 2 points, well, I'm just going to take a value and divide by the previous value. So if I do 40 divided by 80, I'll label this as growth factor, so 40 divided by 80 just gets me 1/2 or 0.5. But I need my growth factor over an interval of 1. This is an interval of 0.5, right? I'm just increasing by 0.5 to go from 1.5 to 2. So that means I need to take this value and raise it to the 1 over whatever this difference is. So the 1 over 0.5. So if in my calculator I do 0.5 to the 1 over 0.5 power, I get 0.25. So that means that my growth factor over an interval of 1 is 0.25. So that will be, when I'm writing my function, that will be my growth factor. All right, remember, this 0.5 was my growth factor over an interval of 0.5 over 1/2. But to get my growth factor over an interval of 1, I needed to raise that to the 1 over the difference in my x's. Now, we still need our y-intercept, right? We have to think back to an x-coordinate of 0. There are several ways that we can do that, but in this case, I think probably the easiest is just to work backwards, right? So I can see that every half I'm multiplying by 1/2. So to go backwards, I would just multiply by 2. That means for an x-coordinate of 1, I would be at 160. Then I get multiply by 2. So at an x-coordinate of 0.5, I would be at 320. And then finally, at an x-coordinate of 0, I would be at 640. All right. The last example, we have an exponential function doubling every 4 hours and going through the point 890. Okay, so again, let's put this in a table. So I know I've got the point 890 on my graph. and we are doubling every 4 hours. So that means I can think about some other coordinates, some other x coordinates as 4 and 0, right? This is happening every 4 hours. So if I think about going 4 hours in the past, if I doubled some value to get to 90, well, that means I would have to take half of 90 to go backwards. That means that this value would have to be 45. All right, and then again, thinking backwards, that would get me to 0. Half of 45 is 22.5. So when I'm writing my function, my starting value, or my y-intercept, is 22.5. Now, my growth factor. We know that doubles means a growth factor of 2, but that is occurring every 4 hours. So if I want to change this to a growth factor every 1 hour, I need to raise 2 to the 1 over 4 power, and then again to the x power. Now, again, if I put 2 to the 1/4 into the calculator, that's going to be an ugly decimal. So I can just leave this as 2 to the 1/4 power. I can just leave this as my final answer to have a nice exact growth factor here. All right, so that's it for these examples. Try the problems on the back of your paper and check your answers on pair assessment.